Hello everyone, I'm Vijay Bhaskar Reddy, Assistant Professor, Department of ECE, KGRT College of Engineering and Technology. As a part of Unit 1 Microprocessor Microcontroller subject, I'm going to discuss about addressing modes concept in today's class. Here a list of addressing modes of 8086 microprocessor are listed out 8 count. Those are immediate addressing mode, register addressing mode, and direct memory addressing mode, and register based indirect addressing mode, register relative addressing mode, based index addressing mode, and relative based index addressing mode, implied addressing mode. Okay, in today's class I'm going to discuss the first 4 addressing modes. Those are very important and which we will use in general all the applications. Nothing but when you are going to write a program, most of the cases when you write general purpose application like arithmetical or logical application, the basic level applications of programs, then we will use, most of the cases we will use, they are the first 4, that is immediate, register, direct memory, or index addressing modes, based indirect addressing mode. Register based indirect addressing mode means register addressing mode, another one. Okay, these are the 4 modes of addressing modes we will use many cases, and of course the remaining 4 also is useful, but there are some sort of special cases we will use like string operations or stack operations or etc input output operations. Okay, we'll discuss in detail one by one. As I told you, today I'm going to discuss the first 4 important addressing modes of 8086 microprocessor. Yes, the first addressing mode is immediate addressing mode, where clearly defines that in this addressing mode the data or the operand is defined directly from external, like you can write data, the data content directly onto the register. Okay, basically what the purpose we are using addressing modes? To define the operand and to access the data in different ways we are using addressing modes. Okay, what are the different ways we are accessing the data or operand information? That gives different types of addressing modes. So one of the addressing mode we are discussing here is immediate addressing mode. In immediate addressing mode, the part of instructions directly given as the immediate data. If you observe here, see 10ABH. 10AB means 10AB is a 16-bit hexadecimal data. 16-bit hexadecimal data, where H represents hexadecimal. Okay, so this hexadecimal data, that is immediate data, we will call this as a immediate data. This immediate data we are copying onto AX register by using instruction move. We are copying this immediate data onto AX register. So we are using one of the operand is the immediate data, and we are by using immediate data we are defining this instruction, and in this way or in this method we are able to define the instruction and accessing the data. That's what we are calling as immediate addressing mode. Not only move operation, you can use any sort of operation. For example, I can perform addition operation between 2 operand. One operand I will use a register, another operand let us use immediate data. As we are discussing about immediate addressing mode, we must use the source operand will be a immediate data. Of course, it is not mandatory to use 16-bit data only. Even though you are using destination 16-bit register, you can use 8-bit data, that is you can write like 54H. So 54H is a hexadecimal data which I want to add with the content of BX register. If already there is a data in BX register, then the data available in BX register as well as this 54 is the immediate data together will be added, and then result will be stored back onto a BX register. As we know that any instruction written in microprocessors, that will store the temporary results onto the destination register or destination operand specified in the instruction itself. Okay, so the immediate addressing mode, in the sense, one of the operand, that is source operand of the instruction defined, must be an immediate data which we have given directly. We are not going to access this data from any other address or any other of register. We are giving direct data as a operand, source operand, and then we are copying or we are performing any sort of operation by using immediate data. I think everyone got clear idea. Now let us move with sort of addressing mode, that is Okay, these are examples. I have listed few examples of immediate addressing mode here. You can see here the 8-bit data is copied into AL register. Here 16-bit data copied into AX register. You can see even when 16-bit data is copying into AX register, as we discussed in the architecture part, where AX register is divided into two 8-bit registers AL and AH. The lower byte of 16-bit data will be stored in AL and higher byte will be stored in AH likewise. And there are different examples we have listed out here. All are like data copying instructions, but whereas the immediate data, if you observe carefully in the all four examples, the source operand is an immediate data itself. Then only we can call it as a immediate addressing mode. Next, the second addressing mode is register addressing mode. The register addressing mode indicates the source operand. If you just compare with this and previous one, immediate addressing mode, in immediate, we just now I told you the source operand must be a immediate data. But in register addressing mode, the source operand must be a register itself, one of the registers, because we have total 14 16-bit registers available in the 8086. Out of those, 4 are general purpose registers we are using. So you can choose any one of the general purpose register, or of course pointer or index register also we can choose as a source operand. Okay, here I have used both are general purpose registers as source and destination, and listed out 2 examples here. You can see this, where 16-bit operation and 8-bit operation. Both the cases I have used the source operand as a BX or BL, that is one of the general purpose register, as a source operand, so that as I am using source operand is a register itself, and then accessing data from this or defining instruction by using both are registers, the destination as the source are register. That's what this type of addressing mode we are calling as register direct. Sometimes we use register addressing mode, or sometimes we will use register direct addressing mode. Why we are using the word direct addressing mode means the data contents from the register directly we are accessing. That's what we also call as register direct addressing mode. Now we can use another instruction where I can perform subtraction operation between 2 operands. Any 2 operands I can take, like I want to perform subtraction operation between 2 operands, DX register and CX register. See, here also I am using both are registers, that is destination is a register, 16-bit register, and source is also 16-bit register. So as I am using source as a 16-bit register here, then it is called as register addressing mode, right? I think everyone got clear idea about this, what makes difference with the different set of addressing modes. Earlier, if you see previous case, the source operand is immediate data. In this case, the source operand is a register we are using, right? So as we are using registers, we are calling as a register addressing mode, right? If everyone got clear idea about this, let's move with the next topic. And before going to the next topic, just I'm giving a small example, like I'm asking you people to write an example of register addressing mode by using any of other instructions in the sense, till now I have used move, add, sub. Apart from this, you can use any of the other instructions and write the example, but you must use the register addressing mode only. I'm giving you 40 seconds of time, then within 40 seconds of time everyone must give at least one example. You can write multiple examples also using different instructions, but you must use register addressing mode only. Yeah, your time start now. Yes. How many of you written examples? I think everyone written at least one examples with this. So you can use different instructions. You can use multiplication. I'll give set of examples here. Multiplication instruction you can use, and you can choose registers. Both the operands will be a register only, CX. Likewise, or else you can use division operation, or else you can use logical operations, any sort of instruction. But what you make sure that the operands which we are using in the instruction for data storage, that must be register only. So likewise you can write any number of examples. Okay, let us move with the next addressing mode, that is direct memory addressing mode. Direct memory addressing mode. Yes, once again you recall the previous two topics which we discussed. Immediate addressing mode, where the source operand is immediate data, and register addressing mode, also called as register direct addressing mode, where the source operand is a register. From that we are taking the data directly for the execution of the instruction. Now the third type is a direct memory addressing mode. What do you mean by direct memory? Instead of using direct data or immediate data, or instead of giving the name of register where data content is available, what we are doing is we are giving an offset address in which the respective data which we need or which we want to use for that particular instruction execution is stored. Means this number, if you see this example, move CL comma 4321H, this 4321H is basically offset address. It is offset address. While discussing about architecture of 8086, I clearly mentioned this offset address in turn added with the base address multiplied with a 10 of segment register, which in turn generate physical address, memory location. That physical address is the one of the memory location of the respective segment register of 64K locations, right? So when it generates physical address, from that physical address, the data available in that physical address will be copied into the CL register. Let us consider this is data segment we are using. Within the data segment, as we know that data segment size is 64 KB, 64K kilobytes of memory locations are available. That one of the memory location where we want to access the data is available. Okay, let us think like this. One of the memory location is this where data is available. That memory location is 24321, or else anything else. The base address may be 5 minutes, you can use the 54321, where the base address or initial address location of data segment will be 50,000, right? Yeah, how to calculate this address location? Yes, clearly mentioned here. The base address multiplied with 10 and added this offset address together will generate the physical address location. This physical address location is one of the memory location of 64 KB, 64 KB of the total data segment register. So from there, the data available, whatever the data available in that particular location, let us consider data available here is some XX, because all are 8-bit locations, so 8-bit data. This XX data will be copied into CL register. Okay, this is the way where we are using one of the operand is a address location, that is offset address location. This offset address in turn added with the base address multiplied with the 10 of segment register will generate a physical address location. That physical address is one of the location of data segment. From there, the data available in that particular address location will be copied into the destination register of operand defined. Okay, this is the way of accessing the information or the data from the memory locations of the respective segment defined. Okay, as we are using the source operand is a memory, as we are using source operand is a memory here, the type of addressing mode we are calling as direct memory addressing mode. You just make clear, we are not using immediate data, we are not using even register. What we are using? We are using memory location or address location of data available as a source operand. That's what this type of addressing mode is called as direct memory addressing mode. You can write more number of examples using different instructions for the same set of addressing mode. I think everyone got clear idea about this, all the three addressing modes. Let us move next, or the fourth addressing mode called register indirect addressing mode. Register indirect addressing mode. Here once again we will recall the small concept just now we learned, that is register direct addressing mode. In register direct addressing mode, if you compare the examples of this and that register direct addressing mode, where we have written instructions in such a way that instruction destination operand comma source operand both are direct register names, both are the names of register, like move ax comma bx, move dx comma cx, add ax comma cx. Likewise, all the cases we used instruction destination operand source operand direct name of registers. That gives register directly, we are accessing the content from the register itself. But when it comes to register indirect, means indirectly we are accessing the data, we are not directly using the register. What instead of that, what we are using address location of the register defined in the instruction. We are defining address location of register in the instruction. Then from that address location of register, nothing but the content of register acts as the offset address. If you remember just now in the third addressing mode, we have seen within brackets, close bracket, we have written number that shows the close bracket number shows offset address location. Here, as we are writing register within the closed brackets, the content of register means whatever the data available in the register acts as a offset address, right? Just compare second, third and this addressing mode. In the second addressing mode, we have used register. So from register, whatever the data available, that data directly we have taken as a input data and copied into the registers, destination registers. And the third addressing mode, we instead of using registers, we specified address location, that is offset address of the one of the location in the main memory. From there we access data. But in this case, instead of using register or address location, we are using one of the register within close bracket. This shows that the content of register, what is the data available in this register, itself acts as a offset address. Itself acts as a offset address, means this offset address in turns added with the base address multiplied with 10 of segment register, then that will generate a physical address of memory location, one of the location of main memory. From there data will be copied onto CX register. I think everyone got a clear idea. The content of BX is acting as a offset address. As we are using the register indirectly, we are not using register directly. Here BX register we are using indirectly to show the data existing somewhere. How we are using this? The content of BX acting as a BX register acting as a offset address. Okay, that's what this type of addressing mode we called as register indirect addressing mode. I think everybody got clear idea about this, the four set of addressing modes of 8086 microprocessor. As we have 8, we will discuss the remaining 4 addressing modes in the next session. But you people remember and again recall the concepts and write more number of examples for each and every type of addressing mode to get clear idea. As I discussed in detail one by one, and at the same time I used a comparison, one-to-one comparison. If you are in a position to compare and then differentiate each and every addressing mode, it is very easy to remember as well as write more number of programming example. Only the way, just compare and find out what makes difference between one-to-one addressing mode. In all the cases, I think everyone got clear idea. All the cases, it's clear. The source operand we are using different ways. If you use immediate address, it is a immediate addressing mode. If you use register, name of register, from there we are getting content directly, that is register addressing mode. If you are using numbers within the closed bracket, which is offset address, that is direct memory addressing mode. And the fourth one which we are discussing now here is, instead of using the content of register directly as a data, the content of register acting as a offset address. How we will specify this? We will specify the register within closed brackets. Always remember this, the closed brackets, within that any register or the data that acts as a offset address itself. Okay, I think everyone got very clear idea about this, all the four types of addressing mode, and you are in a position to write more number of such examples using various instructions available for 8086 microprocessor. Yeah, with this I'm stopping this session. Thank you.